Hey there, everybody. Welcome back. This is Chapter 8. We're working on radicals in Chapter 8. And in 8.1, it's a little bit a long section. I apologize for the length of this first video. It's going to be a little long, but it's all like one topic and like breaking it up. I don't know that I can break it up very well. This is on the nth root of A. So like radicals, we have something like this. This symbol right here is called the radical symbol. You can see it like that. I tend to put the little thing at the end to show like a drop down, like an eave on a house. It shows where it ends. What's inside is called the radicand. That's our A. And the N out front is called the index. Okay. We have the nth root of A equals A to the 1 over N. When we just have a square root of A is A to the 1/2. Where if N equals 2, the index is invisible or not shown. It's implied. Kind of like we don't show A to the first power, it's just implied. So like the 5th root of A is A to the 1/5. And how do we figure out what that is? What does it mean? So like, let's say we have A to the 1 over N to the nth power. This is just some rules we have with exponents. We have A to the first, which is A. So this kind of wraps up to, this is the nth power of A to the 1 over N equals A. So that's how this is kind of like the definition of a radical, what the terminology is. How does it work? If A is greater than 0 and N is greater than 0, then A to the 1 over N power. These are required also for this. A to the 1 over N is the nth root of A. And let's just look at a couple examples. If I have 36 to the 1/2 power, so what you do is you look at this index here, or this number on bottom here, and go, you should treat this as what squared equals 36? And we'll do a different exponent in a sec, or a different index in a second, just to make it clear. This would be 6 squared equals 36. And so, like, that's our answer, is 6. 36 to the 1/2 is 6. That's our question mark. Next example. If we had 27 to the 1/3, what I'm trying to say is what we're going to use this 3 here, and that's going to give us our exponent. What raised to the third power equals 27? 3 cubed is 27. So question mark equals 3, which is 27 to the 1/3 power. Let's do a couple more. We'll do -9 to the 1/2, and we're going to do -8 to the 1/3. Why don't you guys pause the video and try to do what I was just doing here and see what you come up with. Okay. All right, I will assume you did. This translates to what squared equals -9? Nothing does, actually. 3 times 3 would give us 9, and -3 times -3 would give us 9, but nothing gives us -9. We'll try it also with the -8 to the 1/3. What cubed gives us -8? 8 is 2 times 4. 4 is 2 times 2. So 8 is 2 cubed. We're looking at -2 cubed. And with the negative, I can actually write it as -2 cubed as well. Because -2 times -2 times -2 equals -8. So it looks like the answer to this is -2. Okay. We have a bunch of rules that go with radicals and exponents. Let's just make one master list right now. My fingers might numb writing, gripping the pen too tight. All right. So we'll start off with the exponent rules because, believe it or not, exponent rules I think are the easiest ones to deal with. And we have a to the m over n is, we can write it as a to the 1 over n to the m power, or we could write it as a to the m to the 1 over n power. I'm off screen. That's a really new one. We'll say that's a. We'll use here. That's 1. 2 is going to be a to the n times a to the m is a to the n plus m. And along those lines, we'll do division as well. A to the m over a to the n is a to the m minus n. We've seen this top one. If we have an exponent on the inside, exponent on the inside, outside, it equals the exponents multiplied. That's what happened up here. M over n equals m times 1 over n. So rule 3 happened here. Then we have the product. If we've got a times b to the n power, this is a to the n power times b to the n power. And we've also got the division one, a over b to the n power equals a to the n power over b to the n power. We have a to the negative n equals 1 over a to the n. And we have 1 over a to the negative n equals a to the n. So we have a negative exponent. We can move it to the other side of a fraction. Make the exponent positive. And 6 kind of combines 2 and 5. If we've got a over b to the negative n, this is the same thing as b over a to the n. Now we'll add in our rules for radicals. At least what we're starting with. Actually, let's make them all right now. A lot of these rules are going to come from later sections, but we'll add them right now. So you have one complete list right away. So we're going to have a to the m over n. That equals, we can do it as a to the m to the 1 over n power. And this is the nth root of a to the m. N to the mth power. So this becomes the nth root of a to the m power. That's the same on both of those. Just changing the order that we applied this. Okay. See what other rules we want to talk about here. We have, this is kind of related to 4, like 4b. If we have the nth root of a times b, this is the nth root of a times the nth root of b. In fact, it's exactly like 4 if we just changed the n to 1 over n. And we also have a over b, the nth root of that. Make a new line. Nth root of a over b equals the nth root of a over the nth root of b. This is going to be in section 8.4. This is going to be in section 8.5. And we'll do a lot of applying it in 8.6. I think those are the big rules you need to know. Let's see, am I missing one? This shows up in 8.2 also. And one final one, which we'll call 7 because it's kind of new. The square root of -1 equals pi. This is a complex number. This is 8.7, I think. So we'll have a way of dealing with the square roots of negative numbers later on. We don't, it's in general not necessary. This is one master list of what we're going to do. Let's do some examples real quick with using the rules. Okay. In the following, simplify with no negative exponents. 32 to the 3/5. All right, so this is much easier if we write, let's do a prime factorization of 32. So 32 is 8 times 4. That's from our times tables. 4 is 2 times 2. 8 we could do as 2 times 4, or we can just jump straight to 2 times 2 times 2. So 32 is 2 to the 5th power, because there's 5 of them. So this becomes 2 to the 5th power raised to the 3/5. Couple ways to look at it from here. The easiest one is to directly multiply the exponents using that. What rule was it? Let's see. Rule number 3. This becomes 2 cubed, which is 8. Another way of doing it, it's a little bit slower, but it might be a little bit easier to see what's going on. 3 to the 5th power is 1/5 times 3. And so we can like write this as 2 to the 5th power to the 1/5 power cubed. And we're doing that nth root of, or the nth power of a to the 1 over n is a. That's the nth power. 5 and the 1 over 5. These are interchangeable. This just becomes 2. And then the cube comes down and we still get 8. There's a couple ways to do that. Do another example. We're going to do a to the 1/4 times a to the 1/5. When we have the a's multiplied like this, it makes the exponents get added. One denominator to get one exponent here. I will multiply this one by 5 over 5, just grabbing the other denominator. Here I'll use 4 over 4. I end up getting 5 plus 4 over 20. So this ends up being a to the 9 over 20. Okay. Some more simplifying. We've got x cubed, and we're going to raise it to the 1/6 power. So here we multiply exponents, and we get x to the 3/6, which simplifies to x to the 1/2. As we'll see, this is the square root of x, or as we've shown before. If you want to see this as in radical form, this is the 20th root of a to the 9th power. I don't know where we'd have that in real life, but I know there's deep roots in some spots. Next one is x over y to the 2/3 power. Here we can distribute each of these. This is like the cube root of x squared over the cube root of y squared. And in, let's see, will we do it in 8.5? 8.5, we'll see how to clean this up. See how to simplify more. But for now, we're just having you split it up. Y to the negative 1/2 power. So we wanted no negative exponents. So here we put it on the other side of a fraction with the same exponent. This is like over 1. So we just flip that part and put it on the bottom. And so that's kind of like 1 over square root of y. And again, 8.5, we'll see how to make this a little bit cleaner. (27/8 to the negative 2/3 power). Try pausing the video and cleaning it up, see what you get. All right, first thing we're going to do is, there was a rule with a negative exponent and we just flip what's inside. So this becomes 8 over 27, and this becomes 2/3. Then we separate this. And this should clean up a little bit more. 8 is 2 cubed. And 27 is 3 cubed. And both of those are still to the 2/3 power. So 3 times 2/3. 3's cancel, we're left with 2. This is just 2 squared over 3 squared, which is 4/9. All right. Got 2 more, and then this video will be done. Oh no, we got a couple more to do. Let's see. We're going to do x to the negative 7/8 times x to the 4th. All of that will be raised to the negative 3/4. And then we're going to divide by x to the 4/3. All right, so there's a couple ways we can do it. You can distribute the exponent right away as multiplication, or we can try to combine what's on the inside. I like to combine better first. So let's look at next to the negative 7/8 times x to the 4th. This is negative 7/8 plus 4. And if I rewrite 4 as something with a denominator of 8, 4 is 32 divided by 8. So we'll do 32 over 8. So this ends up being negative 7 plus 32 over 8 as the exponent. So x to the 25/8. That's the inside. then we can, it might be easier just to do the multiplication here now. So this top part, when we have something on the outside and something in the inside, we multiply the two exponents. And this is 25 times -3 is -75. 8 times 4 is 32. God, this is getting ugly. We're going to move the negative exponent to the bottom. And now this bottom is, we need to add the exponents. So we need to do 75 over 32 plus 4/3. So again, I'm going to take the other denominator and multiply by it. 3 times 75 is 225, and this is 96. I've got 128 there over 96. So what's 225 plus 128? We got a 3, 5, 353. This ends up being 1 over x to the 353rd power divided by 90, which is the 96th root of x to the 353rd power. Wow, that's awkward. That's awkward. God, that was ugly. This is what happens when you make problems up. So there's a lot of stuff going on there. Let's practice. I've been doing some of this rewriting as radicals. Let's practice doing the rewrite as radicals. Let's start with 7 to the 1/3 power, right with a radical. So the denominator is what goes on the index. And we have 7, this number up top, the numerator becomes the exponent on the inside. So this is the cube root of 7. What about -5 x to the 3/4? Give that a try. Pause the video and give yourself a try at it. All right, I will assume you did. If you tried to apply the 3/4 to the -5, I tricked you. This is -5 times x to the 3/4. So the radical is only on the x. The bottom tells us what the index is, and the numerator tells us the power on the inside. Some people do like radicals really quick like that. This sucks. You want to have a shelf right there. Have a shelf for the index. You really do. And it helps to have like a drop off or eve to show where the radical ends. You'll find as we go through chapter 8, there's a lot of radical stuff here. It will make your life easier. We're going to do the following one, rewrite without a radical. if we have the cube root of 7x to the 5th power, 7 has an invisible 1 exponent. So this becomes 7 to the 1/3, x to the 5/3. We'll do it here with the next one. 3x times the square root of x to the 5 or x to the 5th power. So this is 3x times x to the 5/2. And this is like an x to the 1st. So this ends up being like 3 times x to the 1, which is in with a common denominator is 2/2 plus 5/2. So this ends up being 3x to the 7/2. That's without a radical. If we wanted to put it back in a radical, notice this becomes 3 square root of x to the 7th. So we can move x's or stuff in and out. A radical as needed. But you got to convert it to doing this here. This gives us the same denominator. And this gives us the power on the inside. As we're going to see a little bit more in 8.2. All right. That's it for 8.1. Sorry about the long video. Peace.